Have you ever just wished your computer could, handle a really complex project for you with just one command? And I'm not talking about a simple web search. I mean, we're talking about teaching an AI to navigate websites, juggle different apps, and piece together information just like a real human assistant would. Well, today, we're going to look at some amazing research that's trying to make that a reality. All right, let's just jump right in with a challenge. Imagine for a second you could just say this next request out loud, and your computer would actually get to work and do it all. You're asking it to do a whole bunch of stuff here, right? Multiple searches, calculating a ratio, cross-referencing information from different places, and then putting it all together in one neat little answer. This is exactly the kind of complex, real-world task that researchers are trying to build. This is the world of autonomous GUI agents, AI that can literally see our screen and use our mouse and keyboard just like we do. But there is a huge gap between that dream and where we are right now. And researchers have a name for this gap. They call it the long horizon problem. It's basically the main reason your current smart assistant isn't quite so smart when a task gets even a little bit complicated. Think about it like this. An AI today can totally handle a simple couple-step task like finding an email, no problem. But give it that multi-part research question on the right, it just gets lost. It can't plan ahead, it can't remember the context of what it's doing, and it definitely can't string together dozens of actions to get to the final goal. So why do they fail so badly? Well, it's actually pretty simple. We've been training them on the equivalent of digital kindergarten homework. I mean, the vast majority of the datasets used to train these AI agents have tasks that take, fewer than 10 steps to complete? That's just not how the real world works. And this is where a new benchmark called VeriGUI comes in. And it doesn't just raise the bar, it completely shatters the old standard. Instead of a handful of steps, the average task in VeriGUI takes over 200 steps. That is a massive, massive leap in complexity. So let's get into what makes VeriGUI so different. It's not just about cramming in more steps, it's a whole new playbook. It's a tougher, much more realistic training ground designed specifically to solve that long horizon problem we talked about. This quote really says it all. The old datasets were basically teaching AI simple commands, like how you talk to a toddler. VeriGUI, on the other hand, is like handing an AI a multi-part university research assignment. It demands planning, memory, and the skill to connect all these different pieces of information over a long period of time. So what's the secret sauce? Well, VeriGUI's power really comes from two crucial innovations that just set it apart from everything that came before it. First up is what they call long chain complexity. The tasks are broken down into 4 to 8 big subtasks that all depend on each other. So the AI can't just find one answer and be done. It has to finish part 1 of the research just to unlock what it needs to do for part 2. This forces it to actually plan ahead and remember what it's already done. And number 2 is something called subtask-level verifiability. And honestly, this is huge. Instead of just looking at the final answer and giving it a thumbs up or thumbs down, VeriGUI lets researchers check the AI's work after each major step. It's like a teacher checking each paragraph of your essay instead of just grading the final sentence. You can see exactly where things went off the rails. Okay, so we've got this new, incredibly tough training course. Researchers took the best and brightest AI agents out there today. The deep research agents, the browser-based ones, and they put them through the VeriGUI gauntlet. So the big question is, how did they do? The results were, humbling is a nice way to put it. It was pretty brutal. Across the board, not a single type of AI agent even managed to crack a 10% success rate. The best of the best, these deep research agents, they still only succeeded 8.5% of the time. It's a crystal clear sign that today's AI is just not ready for this level of complexity. This just goes to show how far we really have to go. But you know what? Failure is an amazing teacher. To really get what the challenge is, we can't just know that they fail. We need to understand how they fail. All right, so check this out. An advanced AI agent was given this task. It needed to figure out which streaming service had the best subscriber growth in a certain year, and then dig up all the details on its most expensive original show. And here's where things get really interesting. And you can see the subtle ways these things fail. The AI got the subscriber growth almost right. It rounded up to approximately 39 million instead of the exact 38.64 million. But then look at the VFX companies. The correct answer was a list of 7 different studios. The AI? It only found 1. So the agent didn't just fail in one way. It failed in two really critical ways. It gave out misinformation by being imprecise with the numbers, and it delivered a totally incomplete result by missing most of the required data. It's these kinds of subtle but super critical errors that make the current agents just so unreliable for any serious work. Now, I know what you're thinking. Seeing success rates below 10% feels like a total bust, right? But in the world of research, it's actually the opposite. This isn't a failure, it's a roadmap. These low scores are incredibly valuable because they show us exactly what we need to fix. See, VeriGUI is a breakthrough because it's the first test that actually mirrors how complex it is for humans to use a computer. It gives researchers this high-resolution camera to see exactly where an AI is weak, whether it's in long-term planning or just pulling the right data. This is the tool they need to start building the next generation of truly useful AI assistants. And let's be super clear here, the endgame isn't just about making a better search engine. The ultimate goal is a universal agent. One that can not only browse the web for you, but can also organize your files, create a spreadsheet from scratch, edit a document, and just move seamlessly between all of your different programs. This research is a really critical step toward that future. By creating a proper training ground and a reliable test, VeriGUI is helping build the foundation for agents that could totally change how we interact with our computers. Which leaves us with a pretty provocative final thought, doesn't it? Will these smarter, more capable GUI agents eventually become our digital coworkers?